can we start this session, sir? 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 Sir, shall I start the session, sir? Shall I introduce? Okay, sir. Okay, sir. Sir, am I audible?
Yeah.
Good evening, everyone. I am S. Suma Devi, research scholar from Department of Statistics, Andhra University. Today's session is characteristics of a good sample design, different types of sample designs, techniques of selecting a random sample by Dr. Talari Ganesh, sir, National Institute of Technology, Himachal Pradesh. I would like to introduce Dr. Talari Ganesh, sir. Dr. Talari Ganesh, sir, is an assistant professor in the Department of Mathematics and Scientific Computing, National Institute of Technology, Hamirpur, Himachal Pradesh since 2015. He did his MSc and PhD in statistics from Sri Venkateshwara University, Tirupati, Andhra Pradesh. He worked as faculty at Seshadri Puram Institute of Management Studies, Bangalore, and at Pondicherry University, Puducherry. His main research interests are in the areas of operation research, statistical classification techniques, distribution theory, and data science. He worked on stochastic modeling, time series analysis, and forecasting for diversified data sets using SPSS and R. His current research is focused on multi-choice stochastic transportation problem involving fuzzy programming and evolutionary algorithms. He guided 1 PhD and 6 MSc students and published more than 45 papers in reputed international and national journals, also delivered 20 invited lectures in various workshops and short-term courses. He was an executive council member of Indian Society for Probability and Statistics for the year 2017 to 19. He is life members in various professional bodies such as Indian Society for Probability and Statistics, Operation Society of India, Indian Science Congress Association, Society of Statistics, Computer and Application, and International Society on Multiple Criteria Decision Making. Sir, we can start our session, sir.
Yeah. Thank you. Thank you for inviting me to give this to share some idea about the sampling design. And I would like to thank Professor Muniswamy sir for giving this opportunity to express my views on sampling design and sampling, how to select a random sample and what is the best criteria for the random sampling is involved. So we'll start the session by sharing the PPT. So first we'll discuss about some brief outline about this today's topic. That what is the introduction about the sample and sampling designs, and what is the population, how you can collect the sample, and what will be the exact procedure of the sample and everything. And we'll discuss about the what is the sampling design, that whether it is how many steps are involved in the particular sampling design, what is this particular criteria for selecting the sampling procedure in collecting the sample, and then we'll discuss about the what is sampling error and non-sampling error, and then we'll discuss about some what is the best criteria and characteristics of a good sample design, so that we can discuss about the sampling methods, and there are different types of probability and non-probability samplings are going to discuss here. And some complex random sampling design also will be discussed here, and then what is the use in the real life scenario that will also be discussed in the conclusion part. The first thing is, generally we know that you might have heard about the word population and as well as the sample. So population, as by definition, we can say it is a collection of individuals, and sample is the subpart of the population. You can say it is a subset of the population. You say that the population is a universal set, or maybe omega you can consider as a mathematical terminology. Then sample is a subset of the population. So it's the population is not only is human beings is related, but maybe you can take an example of that. Number of students in a university is a population. So we can say it's a number of individuals who are coming to the picture here, or maybe you can say it is the number of airplanes are maybe represent to the particular company. Then how many are there, or how many overall. You can just the things are even the things are comes under population again. And if you want to make that, actually the population is in two types again. You can come into the picture here. One is finite and infinite. So finite population, it can be countable, as by definition it says that countable population, you can say it is what is a finite population which can be countable, and infinite which cannot be countable, because maybe it takes time, you can say simple. Of course you can count its entire population when you can consider about the infinite population, but it will take time. So the population, because it's in the size is large, then you need a sample to represent to the population. Because just I give an example. A researcher, generally researchers used to do the sampling to evaluate or maybe to justify their new inventions or new findings in the for the comparison with the new market. And maybe you can say it is, if a company wanted to give the some type of products to the market, and they wanted to know that whether it's a product is comparable to the market or competitive to the market or not, then they want to make some calculations or maybe the comparison with the respect to the already existed products in the market. So there, according to them, they cannot compare each and every product, or maybe they cannot compare with the whatever the existing their products. They are not going to compare each and every product which are in the market. So they'll take the sample and they'll test whether it is really affected or not. Or another way, if you say that a researcher, maybe biologist wanted to, or maybe a pharmacist wanted to introduce a new drug to the drug in the market. So he wanted to know about the effects of the drug. So he won't give each and every person, a human being, to know the effect of the drug or outcomes of the drug, okay, adverse effects of the drug. He won't give entire population, right? So the researcher needs the sample. So which sample is more accurate to represent the population? That's more important in this lecture. Even the entire the sample, which consists of having the limited amount from the population, because it's a population is drawn from the sample is drawn from the population. So whether once you take the sample, we are checking about whether it is unbiased, whether you don't have any such type of biasness have been showed to collect the sample, that has to be taken care, and whether it is a true representative population or not, that is also going to be taken care, because there are several items should be taken care while selecting a sample, so that the sample should be true representative to the population. That is the main intention to be discuss about the sampling. Okay. So there are probability sampling. If you consider about we have already I mentioned in the introduction part, outline part. Probability and non-probability samplings are going to be discussed here. So here, generally, once you discuss about the probability sampling, that how each and every individual or each and every item of the particular population should be true representative to the population. Each and every observations in the sample. Say let me here I am considering about the capital N as a population. Okay, small n is the sample. So sample is always subset to the population. That's why which is less than capital N only. Okay, and coming to the sampling. If we word the sampling, I can say that by definition it is selecting the sample from the population. It is a procedure. Sampling is a procedure to select a sample from the population. Okay, so there are any type of sample you can consider. As a researcher, you do what you require. Okay, according to you, then what is required, because you don't want to go with the entire population enumeration. So maybe you can see the number of cancer patients who are suffering with the in entire India. Then in the census, or maybe the government of India want to go to the each and every individual to collect their information, their background every time. Okay, so they take some sample and they proportionate to the population. All the time it's a proportionality. Now coming to the sample design, it's a the sampling design will be same. It's a definite plan to the obtaining the sample from the given population. It refers to the techniques of the procedure researcher would adopt the selecting sample from the sample. You can make a design that where should be, what should be select, and appropriate research study should be select. Whether you are going to make a questionnaire or maybe a schedule or whatever you want to make, that design should be decided by the particular researcher only. And the number of items included in the sample, the size of the sample, sampling design to determine whether before the data collection. Actually, the data collection is also comes under sampling. Data collection comes under sample design. So how you are going to design, how you are going to collect the sample, so that it will be true represent to the population. So first, in sample design, you are going to decide that what type of population. Inverse means it's a population. What type of population it is. So we have some based on your objective, okay, or maybe based on your research study, you are going to decide that what type of universities, what should be studied. Every time you are going to decide that whether my study is somewhat and what type of sample should be taken or what type of population should be considered according to my objective. As a researcher, you have to decide that this is my objective, and based on that, you have to select that okay, I should go with this type of population, whether it is a finite population or infinite population. So it's depend upon you that whether you are going to take a finite population or infinite population. Okay, because you are all going to discuss about the sample, and that sample should be true represent to the population. And of course, in finite or infinite, irrespective of the type of the population, you are going to select the sample. Sampling unit, generally sampling unit, where you are going to make it. So let it be in geographical region, if you are going to consider about that. Maybe a state or district or village may be considered as a sampling unit, or maybe if you construct in a unit such as a house, flat, etc., or maybe a social unit such as family, club, school, etc., it may be considered as an individual. Okay, so the decision has to be taken considering the sampling unit before selecting a sample, because you have to know that selecting the sample which has to be selected. Geographical region, that geographical region, or maybe you are going to households, maybe even here also income groups also. You want to collect the sample observations from the income group of greater than 7 lakhs per annum. Like that, if you you are going to collect this such type of information from the people, then you have to make it that area only. Means that let it be you want to go collect the information of the people who are suffering with the water scarcity, then you have to go with there only, right? So the sampling unit will be based on that where you are locating. Okay, the people who are suffering with the water scarcity, that region, you can say the entire region, that entire region we can consider as a sampling unit. Or maybe the people who are having the, you are going to discuss about the literacy. Okay, literacy rate, but then you have to collect that which area has to be collected, so that should be entire. Maybe you can go with, I want to collect the entire state, what do you say, literacy rate. Then I can go with any state, or maybe I can go with the Kerala, or I can compare with the Bihar. Then maybe you can compare with both the states with either Andhra or Telangana. Then you can go with that. What type of area that you are going to study? What type of area? Then that will be called as a sampling unit. This has to be decided before sampling, before selecting the sample. First, you have to select the universe and select the sampling unit, that where you are going to select. And then third one is source list. Okay, whether it comes under finite population or infinite population. So source, whether you are taking your consideration represent the direction towards go to finite population or infinite population. Then I can say it is source list. I can say it's a sampling frame. First you can make the frame of that. So I should collect the decide the first universe and then sampling unit, whether it is represent to the finite population or infinite population. Okay, and coming to the size of the sample, even the sampling frame you can consider about that what are the parameters that have to be included in the sample. That means that what are the parameters that should be studied in your research study. And size of the sample, this is a big topic that you can consider about that. The size of the sample, there we have to discuss about that what is the significance that you are going to leave, and what type of degrees of freedom that you are going to make, and what is the critical region, that is the rejection region, that your entire sample should be collected from the population. Okay, so the sample should be neither be excessively large or not too small, and it should be an optimum, right? So that the sample size makes an important role to select. Because if you take, let me, the sample size is, if you are going to make the sample population size is more than 6 lakhs, then you have to, sir, just you have decided that maybe 5% of the 60 lakhs people I'm considering as a sample. That instead that this is 3 lakh people are in your sample, it's excessively large. This is size of the sample will be based on your cost. Even we are going to discuss again that what type of sampling design that should be considered. Okay, the size of the sample, and moreover, what is the level of significance that you are going to make. Okay, while deciding the sample size, so what is the precision, means that whether it is how much confidence level that you are going to estimate for the population, and then even that what is the deviation, even that you can make it that how much deviation that should be taken for the larger sample and smaller sample, that the bigger sample and smaller sample. And you can assume that it has some limits. The size of the population must be kept in view of this also limits the sample size, because the parameter interest in research study must be kept in view while deciding the size of the sample. Even you have 100 number of parameters that should be considered in your sample, and then based on that your sample size should also be decided. Let me, you are going to decide only, I can say a researcher wanted to study about the different symptoms of symptoms while studying about a patient. Then you want to make their BMI levels, and forget about the demographic characteristics or demographic variables, and the remaining things, their glucose levels, their BMI, their whether they are suffering with the cardiac arrest or whatever it may be. If you have number of parameters are increasing, then according to that you have to collect your information. The size of the sample should be increase or decrease, that should be decided. Because size of the sample will plays an important role to make it is a true represent to the population. And that too, while deciding the size of the sample, the collecting, because the sampling, right? Collecting the sample from the population, collecting its cost, right? Its cost matters, time matters, okay? Because you have to see the budgetary constraints also, that what type of size should be taken. Okay, of course, you want to make whether what type of level of significance, what type of rejection region, critical region that you are to make, and what type of confidence interval that you are going to make, so that acceptable confidence levels for the estimation. Okay, and what is the variance that should be taken from the population variances needs to be considered, and other than that, unavoidable unavoidable parameters are also included. That what is the cost of the cost to select the sample or to collect the sample from the population, and as well as you have to know that this must budget and this must time. Okay, within this time period, I should complete my entire sampling procedure. So that's also affect, adversely affect or proportional effect to the size of the sample. And here parameters of interest, there's already discussed that what are the parameters that should be considered. Okay, so let me, for instance, for example, if you say that the person is some characteristics in the population, or we may be interested in knowing some average or other maybe measure concerning the population. There may also be important subgroups in the population about whom we would like to make estimate. All this has a strong impact on the sample result. Would be accepted. See, parameters, because the objective, according to your objective, the parameters are also makes an important role, right? Because what type of parameters that you are going to consider, so that your objective also be fulfilled and all the other constraints also be fulfilled, and then it will be representative of. Okay. A budgetary constraints are also been already been discussed, and then seventh one is sampling procedure. What type of, now the original context have been come into the picture. Now we have entered into the what type of procedure to collect the sample. Because sampling is a collection of procedure, right? Sampling is collection of procedure of a sample from the population. This is the procedure. And what type of procedure that you are going to make, that is a more important. So previous one, that whatever we have discussed here, that what type of universe it should be there, and what is the sample size should be there, and then what are the budgetary constraints are there, and what type of sample size that we are going to discuss. These are all the primary, that sampling unit, sampling frame, okay, constraints and parameters and everything. These are all the other studies that we make, because we have decided that this is the frame. Okay, this is the frame, that this is my finite population, and these are all parameters have to be considered, and this is the sample size, and this is my budget, and these are the parameters to be considered, and these are all we have been decided. Now you have decided everything, that what type of procedure that you are going to make. So there are two types of procedure that I have already discussed, mentioned in the introduction part, that which method you can make bias, you can't do any bias, okay, or where there will be a little or very less number of sampling error, and the two cost. What is the criteria for selecting the sampling procedure? Okay, the cost of collecting data and the cost of an incorrect inference resulting from the data. So the researcher must keep in view of two causes of incorrect inference, that is systematic bias and sampling error. These are the two you have to concentrate on. That the systematic bias is that while making the sampling procedure, maybe because it's a systematic bias, is you can identify but you cannot remove it. What does it mean if you identify you can't remove it. Means that you are going to collect some information to the means that you are collecting the sample. Okay, you know that the particular sampling unit is giving the false information that you are observed, but you can't eliminate it. Okay, see, if we ask, then we will discuss about the quota sampling also. There, it comes under non-probability sampling. Okay, in quota sampling, if you ask all the political, what do you say, the MLAs, if you say that MLAs, then what if you ask that what is your income? What is yearly income? They'll give some false information that you have identified that this information is a false, but you can't remove it because you have to collect the sample from that group only. Okay, so that is systematic bias. Okay, the what are the factors that you are identifying the systematic bias? First is inappropriate sampling frame. What is the sampling frame? The sampling frame is that what are the parameters that are going to be involved in the research study. That your sampling frame is also somewhat inappropriate. Okay, so inappropriate sampling frame, it leads to the systematic bias. It leads to the systematic bias. So that even selecting the universe is somewhat biased. Okay, that's what the biased representation of the universe. Okay, if you are biased, then how I can say that it's a too representative population? So there is a systematic bias. Means that systematic bias means error. Two types of error: systematic bias and sampling. And here, second one is defective measuring device. Defecting measuring device means that, let it be a device. If you are making some identifying the defectives of in a company, maybe manufacturing company, a machine has been kept. Okay, has been kept to identify the defective items. Okay, so if the machine is a defective device, then how you can expect that it will be identifying the defective items? So there is an error because you have made it that defective items has to be identified, and that will be leads to again systematic bias. Okay, a system, in survey work, in survey work, systematic bias can result in the questionnaire or the interviewer is a bias. That's why, see, in an interviewer is asking that whether you are suffering from this one, or you are smoking, or you are alcoholic, or you are the drug addict. This type of different questions have been asked. Then it is intentionally you have asked, and then some biasness has been kept into the picture, and then definitely it is the device, or means that the person who is collecting the information is a corrupted. Then we can say it is bias. Means that some error has been identified. The non-respondents, this also comes under systematic bias. Actually, we can't say that it's a some error. Okay, maybe the limited number of, you can say it is a finite population has been there in the in your study. We have taken that what do you say, finite population or finite population, that it is very sensitive case, and a sensitive population have been considered, and then maybe let it be, you can take you want to collect the information about the people who are suffering with the disease of HIV. Let it be, because it's a sensitive one. You want to collect the information about the people. Then how you can ask the people that whether you are suffering with HIV, yes or no, like so, like that the people are non-respondents, right? This also comes under systematic bias, because the sampling unit is very big if you have considered, but the collecting the information or collecting the procedure, means that non-respondents, even they don't want to give in a response even for the questionnaire interviewer, or maybe even the question, we cannot keep that type of question in our what do you say, questioning. Now, in indeterminacy principle, what does it mean by indeterminacy principle? That when you kept under observation that they kept in non-observed situations. See, if a people are working, maybe laborers are working in a particular time, generally they do slowly. Okay, generally they do slowly to complete the entire task. But if you are observing, if you are observing that the person is whether doing or not, then according to that the time it will be increased or decreased. Okay, so here the indeterminacy principle is also comes under systematic bias, because if you observe, then only they'll give the correct information, otherwise wrong information you can get. So based on that wrong information, that will be affect to the estimation, because we are estimating the population based on the sample. If the sample is wrong, then how we can expect that the population will be right? And last one is that natural bias in the reporting of the data. Sometimes the collected information from the different sources you can't avoid it. Some psychological surveys, the people tend to give what they think in the correct answer, rather they are revealing the true feeling. That's what I'm telling you, that we can't avoid it. You know that they are giving the wrong information, the wrong data, but you can't avoid it. You know that. Now, systematic bias is also one type of error. Now we are going to discuss about the sampling. Sampling error is the collecting the sample. If you observe any error, just you can say it's a sampling error. What is it? By definition, it is a sampling error, because sampling error comes under, you are collecting the information, whatever the selection bias you have considered in the earlier one, whatever we have discussed, it also comes under sampling error. Now, to reduce the sampling error, if you increase the number of sample size, then automatically your sampling error will be decreased. Okay, you can identify and you can remove it. Systematic bias, you can identify, you cannot remove it. If you discuss about the same context in the quality control, chance causes chance error and assignable error. Okay. Now, sampling error decreases with the increase of the size of the sample. It has with the smaller magnitude in case of homogeneous population. Okay. If we increase the sample size, the precision can be improved, obviously, but increasing the size of the sample has its source limitation, that is, large sample increase the cost of collecting the data and also enhance the systematic bias, because increasing the cost is also comes under systematic bias. So if you increase the sample size, so that you will reducing the sampling error. Sampling error means relucting to give the information to the respondent or seekers. Okay. So while selecting the sampling procedure, researcher must ensure that the procedure causes a relatively small sampling error and helps to control the systematic bias in a better way. Okay. So sampling error, you have to make it is very less, so that the systematic bias, because both are, you can identify, both are can be identified, only sampling error can be manageable rather the systematic bias. So what is the characteristic of a good sampling design? Good sample design. So from starting of this lecture, we are telling about that it should be a true representative of the population. Designed to be true representative of the sample, and it must be the results in a small sampling error. Okay, if you do the results or whatever the statistical measurements have been made, that it must have a very little sampling error, and it should be a feasible in the context of funds available for the research study. Okay, whatever the research study, some amount has been given by the funding agencies. It should be some the sample design should be in that particular design, or in the particular context, fund availability. Okay, and it must be, sampling design must be such so that the systematic bias control in a better way. Means that sampling error should be low so that the systematic bias in a better way. Okay, and the sample study can be applied in general for universe with a reasonable level of confidence. That's how much you are making the level of significance or level of confidence, so that the sampling design should be better. So now come to the types of sampling designs. So one is, there are broadly divided into two parts, that is probability sampling and non-probability sampling. So probability sampling, in probability, just simple probability, you know that a probability, right? If you take the probability of any random events, each and every observations in the particular sample have an equal chance to be appear. Okay, that's the sampling, probability sampling. Non-probability sampling, there is no such rule to have the equal chance to be appear in the process, to appear in the sample, to be part of the sample. Okay. Now we can discuss about that. The unrestricted sampling comes under what is the probability sampling and non-probability sampling, where that in probability sampling, the methods, that simple random sampling, complex random sampling such as cluster sampling, systematic sampling, stratified sampling, and etc. And coming to the non-probability sampling, you can say it is a convenience sampling, purposive sampling. Okay, that's like quota sampling, judgment sampling, and you can say it is some different types of sampling. You can say it's network sampling. Okay, this all comes under non-probability sampling. So we are going to discuss each and every sampling method, that how it will be performed, and then we can collect the sample. First thing is probability sampling. That I already told you that probability sampling is a technique that which researchers choose a sample from the large population based on the theory of the probability. Simple probability sampling, collecting the sample from the population based on the probability. Simple. Okay, it has the fixed process. The collecting the sample as a fixed process. Let be there are 1,000 members, then 1 by 1,000 is the probability of each and every individual of the population. Okay, every individual in that entire 1,000 people has an equal chance to be part of the population, to be considered as a sample. So now comes the first method, that under probability sampling. We are discussing about the sampling methods under probability sampling only. First one is simple random sampling. It is very simple. Just population you can collect, you can choose bilateral. You can take any observations you are collecting, the entire observation. You can choose randomly. There is no procedure. Randomly, because random means which cannot be predetermined. You know that whether it will be happen or not happening, which cannot be predetermined, is a random, simple random sampling. You are collecting the information, or collecting the sample from the population in a random manner. That is very simple. That's what the method is, simple random sampling. Okay, if let's take an example that have been mentioned in here in the fourth point, that if you in an organization of 500 employees, if HR team decides on conducting team building activities, they would like to prefer picking chips out of a bowl. In this case, each of the 500 employees have an equal opportunity being selected. That's the beauty of the simple random sampling. Here, in simple random sampling, your error will be 0. Almost. There is no specific procedure that you should collect the one sample from this, second sample from this, and third sample from this. Anyway, you can shuffle it all these samples and you can select any 4 if you want. Now come to the cluster sampling. This also comes under probability sampling. Okay. The entire, because of the population size is very heavy, or if you want, the researcher wanted to decide to study the entire population, then cluster sampling is the best one. Okay, simple random sampling, you can identify the sample size and select randomly. But come to the cluster sampling, the researcher wanted to decide that I want to study all the entire population. Better you can choose the cluster sampling, that you can make a clusters. How you can make the clusters? Maybe depend based on the demographic parameters. Like according to age, you can make one cluster. According to gender, you can make another cluster. According to location, another cluster. Different clusters you can make. Okay. Then you can choose that which random sample should be. Okay. So let me, here as an example has been mentioned in there. The US government wishes to evaluate the number of immigrants living in the mainland US. In that case, they can divide into cluster based on the states. Okay. So which state are even which state is having this immigrants are living in the particular state. Based on that, they have made the different states. Okay. The conducting the survey will be more effective as the result will be organized into states provided insightful immigration data. Because if you want to take entire one and each and every one, you can go with that. It will be this error will be coming to the picture here, right? So that's why to overcome that error, all the time you are trying to reducing the error. So here we are trying to reduce the error. There, divide into clusters. Okay. So if the total area interest happens to be big one, the convenient way in which a sample can be taken is divide the entire area number of smaller non-overlapping areas. Means that each and every cluster is different. Heterogeneous area. Each and every cluster is a different. Okay. In cluster sampling, the total population divided into number of relatively small subdivisions, which are themselves clustered in still smaller units, and then some of the clusters are randomly selected for the inclusion of the overall sample. Okay, you have divided entire population into clusters. To select any cluster, apply simple random sampling again. Got it? Only thing is, the researcher wanted to study the entire population. So they divided the entire population into clusters. N number of clusters literally. N number of clusters. Then from that N number of clusters, you can choose any cluster. Any cluster that should be part of the sample. To choosing the cluster from the entire clusters, you can use simple random sampling method. What is the advantage of doing the cluster sampling? Okay, simple thing is it's an economic advantage. Okay, estimate based on the cluster sample is usually more reliable per unit cost. Okay, so because budgetary constraints are very limited, and you want to study the entire population, then cluster sampling is a better. Now area sampling. Same. It is advanced one to cluster sampling. Area sampling is if clusters happen to be some geographic subdivision, then cluster sampling known as area sampling. Simple. The same, just terminology has been changed, the remaining will be same. Okay, if you are collecting the information in geographical oriented, then cluster sample call it as a area sample. It is like that only. Just see, this is one cluster, second cluster, third, fourth, fifth, and sixth cluster. So each and every cluster is different here. Amongst this, you have chosen only two clusters. I'm not choosing the 5 and 6, choosing the entire cluster. This is a cluster. Now coming to the systematic sampling. This also comes under probability sampling. I'll brief it out the systematic sampling. What is the systematic sampling? Actually, every defined interval you will collect the one sample. Every specified interval, systematic sampling. That's what they called as a systematically. Okay, systematically you are collecting the information, collecting the sample. Okay, because every regular intervals you are collecting the sample. To select the first sample, starting point. Okay, to select the starting point, you require again simple random sampling. Okay, see the systematic sample, it has a predefined range, means that every interval I have to collect one sample. Every interval I have to collect. It means that you can first you can fix it one interval. Maybe every 50th observation I have to consider as one sample. Let it be 0 to 50th, 50th to 100, 100 to 150, 150 to 200, like that. Every 50th observation, okay, is taken as a one, taken to be or collecting as a sample, and the remaining 49 will be leave it. Just means that the particular one and regular interval is represent to the entire 50 people. Okay, so to select the first one is again simple random sample. I'll tell you that every interval, first one we have selected this one, two intervals, fifth one, two intervals, eighth one, two intervals, 11th one, like that. Every two intervals means that you have made a specified range that every two intervals have to get to. As an example, for the systematic sampling, let me, for example, if 4% sample is desired, means that you want 4% of the sample is desired. The first item would be selected randomly from the first 25, and thereafter every 25th item would be automatically be included. So first to 25, among 25 observations or 25 people, you have to select one person, right? Maybe you have 100. You have divided into 4 parts. From first 25, you don't know which one has to be selected, whether it's the first one, second one, third one, or 25th one. Okay, so that's why to select that one, you can select simple random. You can use simple random sampling to select one sample from 25 observations. Next 26 observation, second, then 51st observation, third one, then 76th observation will be fourth one, like that. Every 25th item would be automatically included in the sample, because it's a systematically we are collecting the sample for the fixed interval. Of course, it is not a random sample, but selecting the first sample is systematic, is random. That's why it comes under probability sampling. What is the advantage of systematic sampling? It can be taken as an improvement over the simple random sample in much a way, in as much as the systematic sample is spread over spread more evenly over the entire population. Okay, and it is easy. Okay, very less cost to collect the sample. When easy, convenient to collect the information if you have larger population. What's the disadvantages of this one? Main disadvantage is that to collect the sample, it is insufficient. What is inefficient? Inefficient means that an example has been given. Every 10 to 25th item produced by a certain production process is defective. If you are selected a 4% of the 4% sample of the items of this process in systematic manner, so we can't get it the exact defective item there. So how you can say that next 26th observation is a defective, 25th item is a defective, or maybe 76th item is a defective, or maybe 101th item is a defective. Okay, so you can't make it. This is the main disadvantage of in systematic sample. Of course, procedure and everything is a very less cost and easier method, but the representation is not up to the mark. Now we can go with the stratified sample. Now you can make in stratified random sampling. First, stratified it. What does I mean by stratified? Stratum, homogeneous subgroup. Stratum is a homogeneous subgroup, and from that you can make it. Let it be. The example has been given here. You want to collect the annual income, annual family income groups. I can make it divided into the stratums. Stratums means subgroups. Some groups I'm going to make it. So there 20 less than 20,000 people, less than 20,000 family income, then 21,000 to the 30,000, 31,000, 40,000, 41,000, 50,000, and etc. Like that I can make it is in a group. Less than 20,000, who are the people are having the family income, it is a homogeneous. It is totally heterogeneous to the another subgroup, right? One group is a homogeneous, other group is another homogeneous, and because if you make the correlation between them, it is not at all related because it is a heterogeneous. Each stratum is heterogeneous, but inside the stratum is a homogeneous. Okay. So let me how you can make a form a stratum. How you can make a forming a stratum based on just it's a basis of the common characteristic of item that we put in the stratum. What does it mean? That various strata be formed in such a way as ensure elements being most homogeneous within each stratum and most heterogeneous between the different strata. That's it. That's what I'm telling you that. Inside the stratum is homogeneous, outside that it is a heterogeneous totally. So one stratum to the another stratum is totally different, heterogeneous. And how should items be selected from each stratum? How I can select? So for selection of items in this sample from each stratum, result is that of the simple random sample again. So you might have observed that each and every probability sampling, to select one sample at least you have to use simple random sampling. That is the beauty of the simple random sampling. Let me, you can take an example. There is the 30, the sample size should be 30. You have decided that you have to collect only 30 samples out of 8,000 population. Okay. Now we have divided into three stratums. One stratum having 4,000, second stratum having 2,400, and third stratum having 1,600 items. Okay. So because of if represents PA represents the proportion of the population, of stratum I, and n represents the total sample size, because that is what you are going to make, total size, and the proportion is total. Then each stratum, how many samples should be taken, that is n into particular proportion, population proportion. Okay, so let be n1 4000 you have taken, because it has been mentioned that's n1 4000, and what will be the p1? 4000 divided by entire population. Okay, so if you multiply with 30, because your desired sample size is 30, so that from first stratum you have to take 15 number of samples. From the second one, 9 number of samples. From third one, 6 number of samples. So that 15 plus 9 plus 6, you can get 30 desired sample size. Okay, proportionately you are trying to collect the sample. Okay, proportionate you are collecting the sample. And if you take it, say, disproportionate sampling design. How you can make a disproportionate sampling design? Because larger sample size must have, more variable strata, and smaller sample have the less variable strata generally. Because high number of samples means sample size of one stratum is very, highest number or maybe more variable, more items, then variability or means deviation is very high, and compared to the small samples, the variable is less. Okay, so that you have to include a standard deviation. So it has been taken an example, a population is divided into 3 stratum, that is n1 is 5000, n2 is 2000, and n3 is 3000. Okay, there are standard deviations in this particular stratum, that is first one is 15, second one is 18, and third one is just 5. How should a sample size, that is my desired sample size is 84, to be collected in these 3 stratums, so that optimum allocation using disproportionate sampling design. So this is the procedure that based on this formula Ni. So I is the ith sample. How many samples has to be taken? So this is the one. N1 is n into n1 sigma 1, and again total 1. That is what we have made. So from first stratum you have to take 50 samples. Second stratum you have to take 24 samples, and third one is you can take 10 samples, so that it is 84 sample observations or 84 desired sample size should be collected from these 3 stratums. But total 10,000 population size is 10,000. You have considered the entire 10,000. You have considered the entire 10,000. From 10,000, you have divided into stratums, homogeneous subgroups. Stratum is homogeneous subgroups. So once you have collected, divided into homogeneous subgroups, then each and every subgroup will be calculated based on the proportional. So now, what is the uses of random sum? So these are the methods that have been discussed in probability sampling. So what is the uses? First thing is, it reduces the sample bias. What does it mean by sample bias? The information whatever you are taking, it cannot be a biasness. It should not be any related to anything, because biasness, you know that you are giving some support to the another one, supporting. The second thing is, it's a diverse population. When the population is vast and diverse, it is essential to have adequate representation so that the data is not skewed toward one demographic. For example, suppose square would be like to understand the people that could make a point of a scale device. In that case, a survey conducted many sample people across US in industries or socioeconomic backgrounds. And third one is, create an accurate sample. Because of the probability sampling, you can make exact, accurate sample size. Now we are going to discuss about the non-probability sample. If it all follows any such type of probability sampling here, then just collecting the information, collecting the sample from the population, their own procedures. They are not at all discuss about the any equal opportunity should be there, and this error should be very less. No, they won't. They do their own method. Okay. First one is convenience sampling. According to the convenience, they are going to give the collect sample from the population. Because it's an easy access, because a survey, a customer at a mall or a passenger passes by on a bus street. Okay, it is usually termed as a convenience sampling because the researcher ease of carrying out and getting in touch with the subjects. Simple. Convenience means according to your convenience, you are collecting your information. Then where you can make it is to represent to the population. Okay, because the resource with the resource limitations, the initial stages of research, convenience sampling is used because you want to make it very easy and very fast also. Very easy and very fast in initial stages, then convenience sampling is a better one. Let it be in startups and NGOs usually conduct the convenience sampling at the mall to distribute the pamphlets for the upcoming event or promotion, because they won't ask anything. They won't go and explain about their things in a better way. They'll give some simple. Or you can give that it's a convenience sampling. Is advertisements also comes under convenience sampling? Okay, they want to target the people. Just according to them, they give it. Now, voluntary sampling. Voluntary sampling. What does it mean? Voluntary sampling. The volunteers must be screened so as to get a set of characteristics suitable for the purpose of the survey. Best example is individuals with a particular disease. Just voluntarily they have to come and give their input. Voluntary sampling, because you want to collect the information only for kidney patients, CKD patients, chronic kidney disease patients. Then you have to go with them only. Voluntary sampling. Okay, this method can be have the large selection bias, but it's sometimes necessary because for ethical reasons, volunteers with a particular medical conditions may have to be solicited for some medical experiments, right? So that's why, of course, it has some selection bias, large amount of selection bias, but it required to find or collect this first type of information. Okay. Another example that you will consider the voluntary sampling is that callers to, because just a debate is going on or maybe a discussion is going on, they are asking about the opinions. Those are interested, they are going to call because they say that any objections or any discussion is interested, people can call so and so number. There will be any debate is going on, then they are scrolling out that to discuss or any points relating to this matter, you can call to this number. The people, interested people can call and they discuss, they share their knowledge. That is voluntary, because voluntarily involving in the sampling. Okay, voluntarily involving in the sampling. And third one is purposive sampling, or you can say judgment sampling. The researcher will collect the sample on a purposively. It's purely on purpose only. The information the sample collects purely on purpose. The simple, the example had been mentioned in this point that you want to understand the thought process of people interested in studying their master's degree. You will ask that whether you are interested to doing master degree, yes or no. It's simple, that's it. Purposely they'll ask. Now comes to the quota sampling. These are all non-random sampling one. Okay, quota sampling is they'll fix a pre-standard. First, they'll fix a pre-standard, and that case, in that, the frame, whatever the sample has been formed based on specific standards or characteristics or attributes, the same quality found in the total population. Okay, quota sampling is somewhat similar to the stratified sampling, because quota this divided into the different statums. Okay, but in stratified sampling, selecting each and every sample from the stratum is taking a random SRS, simple random sampling. But here it's not like that. Units are selected because that's what it differs the how the units are selected in the each and every quota. Okay, for example, a cigarette company wants to find out what age group prefers what brand of cigarette in a particular city. This applies the survey quota on the age groups of 21 to 30, 31 to 40, 41 to 50, and 51 plus. From this information, the researcher gauges the smoking how the trend is going on. The quota has been divided. Now, network sampling or snowball sampling. Okay, very sensitive issues. You want to collect the information about the sensitive issues, then network sampling is the best method. It comes under non-sampling, non-probability sampling. Okay, of course, even the collecting the information, collecting the sample is very difficult in network sampling. Let we want to ask the people to collect the or get the information about the shelters, to get the shelters people who are maybe illegal immigrants will be extremely challenging, because using the snowball theory, the researcher can track a few categories to interview and derive the result. Simple. Because they'll give the wrong information. Simple. They'll give the wrong information. Even another way, they'll ask that they collected the information about the HIV people who are suffering with that particular disease. Okay, so there also the collecting the information is very, 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 very sensitive. But still, a researcher wanted to study the particular objective, then network sampling should be the best one. Because here in this situation, the sample size is very maybe not that much accurate. So what is the advantages of non-probability sampling? Because you can take any non-probability sampling, it is very quick and convenient. According to their purpose, according to their convenience, according to their quota, and anyone, it is very quick and convenient. And moreover, it is inexpensive. You can't make that much expensive to collect the information there. Non-probability sample. And it reduces the respondent burden. Okay, you can give this. Let me give an example of that in volunteer sampling. There, the respondents themselves will give the information to you. What is the disadvantages of non-probability sampling? Selection bias. So in order to make inferences about the population, it requires strong assumption about the similarity between the sample and the population, even though the respondents are self-selected. So due to the selection bias presented in all non-probability samples, whatever the non-probability sample you have been discussed throughout, every sampling procedure, selection bias is very high, or I can say systematic bias. Okay. When the generalization to the whole population to be made, probability sampling should be preferred instead. That's what, because there in probability sampling, systematic bias is very less, so that sampling error also will be reduced. And second thing is designed as a non-coverage. Because of the quota sampling, if you go to the quota sampling, we are not at all discussing about the other people who are desired, who are not desired. So definitely it is non-coverage, because biasly you are going. Just simple I can say, biasly I am going to do the sampling. And moreover, it's difficult to assess in the quality in a sample. Because quality of the sample means it cannot represent to the true population. Whatever the sample, it's not represented. Even the estimating the sampling errors also, it cannot be possible to compute. Then how do you decide on the type of sampling to use? What type of sampling that should be used? It's all depend upon the objective. What you are going to study. So based on that, you have to decide your sampling. Because you have to concentrate on the what is the budget, okay? What is the type of the sample? What is the type of the population? Whether it is a finite or infinite. So what is the sampling unit, sampling frame, parameters? These are all will be decided that which type of sampling to be used, sampling method to be used. Okay. And second thing is the whatever the sampling method you have been selecting, you are going to select, that should be satisfies your objective. What you have been said, objective. Okay, and whether you have to examine whether it is reaching to our goal or not before selecting the sampling method. Whether the method or whatever the sampling method is related to your goal or maybe your objective, whether you are truly represent to the objective or not, whether satisfying your objective or not. So according to the researcher, you can choose your best method. How to select a random sample? So whatever the procedure we have been discussed so far, okay. So you can do all this. Whether you can go with questionnaire or maybe schedule, okay. Any type of method that you are going to make, that will be represented to the sampler, because randomly you are collecting the information. So come to the random sample from an infinite universe. It is relatively difficult to explain the concept of random sample from infinite population. However, a few examples, let me say, suppose we consider 20 throws of a fair dice of a sample from the hypothetically infinite population, which consists of the result of the all possible throws of the day. We have made only 20 throws, and you are trying to estimate the infinite number of throws, and this will be the results. Okay. So let me in particular getting number 1 from each throw, and 20 throws all are independent, then the sample is a random. Similarly, it would be said the sampling from an infinite population, if we sample with the replacement from finite population, and our sample would be considered as a random sample if each draw all elements of the population has the same probability being selected and successive draws happening are independent. You are making only from the finite, you are trying to go with the infinite number of times, the same thing will be happen. That's what normal theory will come into the picture. Normal distribution theory will come into the picture here. Complex random sampling design. So probability sampling under restricted sampling techniques. Okay. The such designs may as well as be called as mixed sampling designs. Okay. For many such designs may represent a combination of probability and non-probability sampling. The complex random sampling design. Sometimes at uh, deciding to a objective or deciding to reach some objective, then you can use mixing of both probability and non-probability sampling. What are that mixing of both? Multi-stage sampling. Multi-stage sampling, it is further of cluster sampling only. It's a clustering sampling. Cluster sampling, whatever have been discussed. Suppose we want to investigate a working efficiency of a nationalized banks in India, and we want to take a sample from few banks for this purpose. Okay. The first stage, select a large primary sampling unit, such as states in a country. Then we may select certain districts and interview all banks in the chosen districts. This would be represented as two-stage sampling. First, you have collected all the nationalized banks information and divided into the states and districts. So, stage wise you are making the sampling. Or if you make again and again and again, then it will come under multi-stage sampling. It is two-stage sampling that has been discussed in the example. Because the information, all the census, instead of taking a census of all banks within the selected districts, we select certain towns and interview all banks in the chosen towns. This will be represented the three-stage sampling. Because districts come to the towns. Again, the banks selected towns, we randomly sample banks from each selected town, then in case of using a four-stage sampling. First, entire country be divided into states, and states will be districts, and district will be towns, and town will be again one or two banks. And selecting each and entire India, you have selected one or two states, and from one or two states you have selected maybe 10 districts. Among 10 districts, you have selected only 2 or 3 state towns, and among the town, you have selected maybe 5 or 6 nationalized banks in the country. So, stage by stage, every stage you have using sampling, random sampling. Okay. What are the advantages of the sampling design, this multi-stage sampling design? It is easier to administrator. Sample for a given cost under multi-stage sampling, because the sequential clustering, whereas this is not possible in most of the simple designs, because every stage you are making one cluster. First stage you are divided into states, that is a cluster, and second stage you have divided into districts, that is also cluster, and third stage you have divided into towns, that is also districts, that is also towns, that is also cluster. Again towns you have divided homogeneous one, that is also cluster. So sampling with probability proportional to size. In case of the unit do not have the same number or approximately same number of elements, it is considered appropriate to use this random sample selection process, where the probability of each cluster being included in the sample proportional to the size of the cluster. So whatever we have been discussed in a cluster sampling, same theory will be applicable in the multi-stage sampling also. Now come to the sequential sampling. Here you are not at all fixed the sample size here. You are not decided that this much of sample size should be decided taken. Okay? But according to the mathematical decision rules and the basis of information yielded, just as a survey progresses. Because you are deciding your sample size based on that how you are going to make a survey. This is generally in sequential sampling. It is generally used in statistical quality control, that is acceptance sampling plans. Okay, every time whether you have collected the defective and remove it and then do it again, do the sampling again and again. Okay. So in the conclusion part, so here we have discussed brief discussion about the sampling designs. Okay, and we have discussed about that what should be the sample size. Okay, how you can whether you have to concentrate on the what type of error should be concentrated so that it should not be included in the sample that you have been collected from the population, that is sampling error and non-sampling error, or you can say systematic bias. And we have discussed about the probability and non-probability sampling. In probability sampling, we have discussed different methods of sampling techniques, and non-probability sampling also we have discussed. Okay, and each and every method have been elaborately discussed in this one. Then just in conclusion, in final one, I can say that a researcher wanted to study according to his or her objective. They have to decide what is the population size, what is the sample size. Okay, whether it has to be collected from the finite population or infinite population. So what is the budget that has to be collecting the sample, and what is the sampling frame, means that what is the area has to be collected, what are the parameters should be collected. These are all will be decided by the researcher. Okay, hope this is will be fine from my side. Any queries, please? Are you there?
Students, if you have any queries, you can ask, sir.
So meanwhile, I'll share the entire PPT that can be helpful to you to study the entire topic. Okay, I'll share to the organizer.
Okay, sir.
Okay, so that that's the same PPT can be shared to the entire participants.
Okay, sir. Thank you, sir. Thank you for your wonderful and informative session.
Thank you.
Thank you, sir.
And in this context, I would like to thank Professor Muniswamy sir for giving this opportunity to share the my thoughts for the these researchers who are really seeking about deciding about their sample and what is the population should be considered, and what are the objectives have to be considered in their research study, this and all. So as a statistician, we are always ready to help the people who are really seeking about the deciding about the sample size, and as well as the what type of sampling method should be considered, whether we are going to make questionnaire or schedule or whatever it may be, you can consider. We are ready to help you, and feel free to ask any such type of requirements from your end. Then we are ready to help you. Thank you.
Thank you, sir.
Okay, can I leave?
Okay, sir. Thank you, sir.
Thank you. Thank you.
देशाचे